Hello, everyone. Thank you so much for being here. This is another workshop we have with Jennifer from ICP, Internet Computer Protocol. We are first of all, thank you, Jennifer, for being here. We really appreciate it. Thank you for the time you're putting. May I know where you're located?
I'm based in Seattle.
Oh, based in Seattle. Okay, very close by, very close to Vancouver. That's amazing.
Thank you so much for being.
I think I'm unable to hear at the moment.
Okay, can you hear me now?
I can hear you now.
Okay,
Yeah.
perfect. Yeah, I was just rambling on for a little bit. I was just something we were talking about. Dominic Williams, the founder of the Definity Foundation. He had this quote that all these crypto companies out there, they're like trying to build their systems and then trying to like be the AWS killer. And at the end of the day, they can't store too much like of data onto the blockchain. And with the AI boom happening right now, and you got all these vast amounts of data set, how can you leverage this decentralized aspect to make decentralized AI and have the proof that the operations are happening? I don't want to get into it because you have your own thing, and Bahar, I'll pass it on to you.
Thank you. Yeah, I'm also so excited to learn more about ICP and how we can, how everything can be on chain and can be faster, cheaper. I have a lot of questions, so I will be commenting a lot as well. Thank you for everyone who's joining us in this live stream, in this workshop. I know that people will be slowly joining us more, so I will give everyone a little bit more time. So I want to just go through what we are doing and who we are. We are a non-for-profit organization. We help startups go from zero finding their next 10K customers or raising fund. The whole idea is to we have an accelerator startup studio, and we host programs, workshops such as this for our community members. Our communities are founders, builders, creators, and even investors. We are on a mission to onboard the next generation of creators and builders into the imagination age. And if you don't know what imagination age is, so do you know when the time where we were texting, we started texting to each other, the time of Facebook, the time of all of those emails, cool stuff? That was in the past. That was information age. And now we are in the imagination age, in the age of the abundance of resources and access to the cool technology such as AI, Web3, blockchain, ChatGPT, AR, VR, that kind of enabling us to be able to realize any ideas we have in mind. So we thought right now in these days that you can go from prompt to anything in matters of minutes or seconds. Why not test this and see if you can build $1 billion startup in 3 days? If you have a team, if you have all the resources you need in 3 days. So we started working on Be Loud on Build AI Hackathon. It's 3 days of going from idea to MVP to finding users for your product with cool prizes and investors as judges at the end, that they can support you. They can support your journey even after the hackathon. Feel free to join in. If you have any friends, any colleagues, anyone who would like to invite them, feel free to invite them. We would love to have more people on board. And I think that's enough of me talking, and we can. Jennifer, the stage is yours. You feel free to start your presentation. I will remove myself. You can add your presentation if you have there.
Yeah, just one moment. Give me just.
For sure. So while Jennifer's trying to figure out the logistics of it, thank you so much for everyone coming. We got Babak, Sarang, sorry if I'm probably not pronouncing that right. Haravi, Anita, Xavier, Jacob, good to see you here. Yeah, it's we're super excited for the hackathon. Have you all introduced yourself in the Discord yet? I feel like you have. Press 1. Yes, something. Okay. Okay. What else? What else should we do to kill time while we wait for Jennifer to walk through it? How was your day, Bahar?
It's great. It's been fantastic. It's been pretty busy. I'm so excited about hackathon, and I'm kind of like excited and a little bit stressed as well because it's the first time we are doing something this large scale, and I met almost every single participant, and it's been amazing meeting everyone and talking about their ideas. Let us know how excited you are from 0 to 10 for the hackathon.
Yeah, I'm super excited for it. And for all of you who booked a meeting for the interview and didn't show up, I do want to talk to you later. Some of you booked meetings at 6 a.m. You got us to wake up and didn't show up. Don't do that, please. We do like games, but not that kind of game. Um, so a hackathon, 54 hours, one idea to an MVP to a user. So essentially, we want you to like start from scratch, challenge yourself, use that peer pressure, people around you, the mentors, resources, prizes as an incentive to create that $1 billion startup. Totally possible, totally doable. Folks have done it in SF and previous hackathons. We'll share the success stories, and you're going to be the next success stories that you look into this and be like, hey, I was at this hackathon, and then I met my co-founder. We created something great, and we went on to raise funds, and then we help you with it. So just come in with that mindset that you're ready to like take on the world, and you know it's a good opportunity. If we weren't doing this, I'd like to participate myself as well. Yeah, just take the ultimate benefit you can from it. Great to have you, Jennifer. Are we all set with your screen and the setup?
Yes, I am. Yeah, I think I accidentally just closed out the session. But yeah, thanks so much for the patience, everyone. While we get set up here. Cool. Yeah, so I should now be able to share my screen. Yeah, and I also love the fact that you guys are doing like so much just in the Pacific Northwest, especially with helping more early stage companies, because I think that there is kind of a huge desire for new startups just in the area. And yeah, I think a lot of people just want to just kind of tinker around. But yeah, they just kind of need that space. So thank you so much for that. And with that, I can now share my screen and just talk more about ICP.
Go for it. Super excited. You can press the big plus button at the bottom, and then it'll bring your screen up. We'll share it, and whenever you're ready, take it over.
Yep, I think it's coming up here in a second. All right. Awesome, guys. Thank you so much for joining the session today. Today, I'll be talking about building decentralized AI, specifically on ICP, the Internet Computer. I'm Jennifer Tran. I'm a developer relations engineer at Dfinity, which is a major contributor to ICP. You can follow me at jkim_tran on Twitter. You can also find me on LinkedIn. I'm more than happy to continue the conversation after this workshop, but I also should be online during the workshop as well. So please feel free to ask any questions throughout the week, as well as starting next week on the 10th while you guys are packing. And so let's dive in, like what exactly is decentralized AI? So decentralized AI, or DAI, is an approach to which AI uses blockchain technology in some sort of way. So in distributing, processing, storing data across like different nodes, which are what make up the blockchain. And yeah, I'll talk a little bit more about the use cases that we're seeing on ICP. But now some of the value of DAI, like why would you use blockchain with AI, is first the data transparency. If you train your model on the blockchain, essentially, there just be more transparency on what data is being used to train that model. And that results in a lot of really favorable outcomes. Like, for example, you could then be able to help creators of this data like monetize a lot better. We have a use case of that happening already on ICP. There's like better data ownership. Creators really are able to kind of own their data. I think some controversy with AI is a lot of data is being used to train without the consent of creators, and this potentially can help solve those issues. There's better, there's in general like this better like privacy, like essentially like AI in itself. Yeah, like I mentioned, like someone could train any sort of data right now without the creator's consent. In this case, if there's our transparent means, just understanding where the AI, like where the model is being trained, essentially, creators can maybe tell someone that they don't want their data or their creation be trained, being used to train a model. So it kind of gives like creators like more privacy. And the last one is like kind of what Bora was alluding to, is kind of this product protection. There are like a lot of AI teams are hosting their services on AWS or on Google Cloud, which are competitors, which AWS and Google themselves, they are building AI products, and they essentially could be competitors to an early stage AI product. So therefore, yeah, like by hosting your AI service on a decentralized cloud, such as ICP, you really are able to protect yourselves from any competitors. You're able to just like still like have access to your model, to your service, despite any malicious competitors. So I think that in itself is actually very valuable to a lot of early stage companies, because I think there are reports of certain competitors shutting down certain AI products because they are competing with the products that they are building themselves. And so, yeah, here are some of the use cases that might be like you might be able to build during like the 3-day hackathon. So, for example, potentially you can create like some sort of generative art for NFTs. Think of like a combination of Midjourney and NFTs. So NFTs are these digital certificates that represent something. So in this case, a lot of times NFTs, people associate them with artwork or images. And so you can create these NFTs that can or you can automatically generate images and then maybe mint them as NFTs. Another use case is an AI chatbot trained on specific data, and then that data is then every single time someone uses that chatbot, whenever that data is being used to provide an answer to the user, you're able to maybe track that usage using like a blockchain like backend, and then from there, then you can then distribute funds or distribute monetization to creators of that data. That's based on the tracking data that you have provided. And a team on ICP is working on this exact use case called Datapon, and this QR code directs you to their GitHub and their application. So yeah, you can definitely take a look at what they're doing. And some other inspiration from ecosystem teams include, for example, like modclub.ai. So they are an AI-powered user verification and content moderation platform. And what they do is, so what they have been trying to do is, every single, so they have like those who like moderate content, and what they do is now they're practically taking their content moderators and then using them to help train a model that they're building out for like automatic content moderation. And they're actually are running a full inference on chain. Another example is ICP GPT. They're a fully on-chain chat GPT. So practically, think of a chat GPT. They actually then run an inference, like a small inference model, like on a smart contract. So let's dive into like what exactly is ICP. There's a couple components and like why is it helpful for DAI. You kind of have already heard of some like ecosystem products building on decentralized AI, and there will be some other resources to discover more. But let's talk a little bit more on what exactly is ICP. So ICP is the Internet Computer. It is a permissionless blockchain itself. So you might have heard of these chains such as Solana, Ethereum. In a way, like ICP itself, its own like L1 layer. You can use it like that. But also there's other aspects I think that makes ICP, very interesting. So for example, ICP is a crypto cloud. So what I mean by a crypto cloud is you can actually do kind of a lot more than just like what a standard blockchain does. So because ICP can store smart contracts, allow you to store a lot more data. You can, for example, serve like a full decentralized application just directly on the protocol. So on other blockchains, you could only maybe have like a small smart contract, and then maybe some other services you might have to host somewhere else. But ICP gives you this all-encompassing solution where you can interact with a blockchain and also be able to host any services that you would like. In this case, like any front end and any back end, and that's why like you were able to create this whole like decentralized infrastructure. And the other interesting aspect is this multi-chain layer. We call it chain fusion. So ICP itself is its own blockchain, but the value of it is actually you can connect to other blockchains using ICP. So with chain fusion technology, ICP canister smart contracts can actually like call and connect to Bitcoin and EVM. So for example, like an ICP canister smart contract, you can actually create like a Ethereum like public key or like wallet address directly in ICP canister smart contract, and then be able to then sign for that public key or like that wallet address. And so like what's really great is like anyone that wants to build like a multi-chain application, they can just use ICP and then be able to interact with like Bitcoin and EVM just directly in that one ICP canister smart contract. And in the future, we will also be integrating like Solana as well as Bitcoin ordinals/runes. So then you'll be able to interact with a lot more chains in the future. And then I mentioned like ICP canister smart contracts like a couple of times for those who are not as familiar with blockchain. So the blockchain has in order to write code to the blockchain. There are these like code snippet, or these code snippets kind of like called like smart contracts. And I think like what's really great about ICP is because like we can store so much data compared to like other smart contracts on other chains. And so like practically for ICP, the term that we use for smart contracts are canisters, but you hear like smart contracts and canisters, quite interchangeably. And like I mentioned, like ICP canister smart contract can store code, it can store data. It's where you host your code. In this case, like if you want to build, in this case, like we'll build an example towards the end. That's like where you would build your code and also be able to store your data as well into this canister. And this link here provides an just an overview on canisters. So if you want to kind of like deep dive a little bit more on how canisters work, like what you can build, I think that this is a great resource. So why ICP for decentralized AI? I've touched upon these, but specifically, ICP canister smart contracts allow for 4 gigs of heap memory. This really allows you to like run like smaller LLMs, which is kind of crazy because for other chains, I believe this number is only in the megabytes. And so it's actually impossible to run an LLM on other chains. And then the other value is the 400 gigs of stable memory. So stable memory is like the memory like you can't just like remove when you do like an upgrade. So like this is practically like the memory, like the storage that you'll always have. So in this case, that stable memory, you have 400 gigs of that. So like that's like considerable, like a lot. Like for example, I think like my Google Drive probably only has like 20 gigs of memory, and you can imagine I have like so many files going back to like university. So that's quite a lot for even just the average person. So yeah, this stores a lot of stable information. So combining that, like you can run small LLMs, but also if you wanted to, for example, store any data like a hash map, you're able to do that as well. So I think like I've talked about that example where you can create this AI chatbot that can track every single time that a piece of data is being used. ICP is great for that use case because like you can run the small LLM that powers this chatbot, but then let's just say like every single time someone uses that chatbot, you can kind of track what they might have used it for and like what data points that chatbot did use. And like I mentioned, chain fusion is also a really great use case as well. I talked about in that use case where about AI chatbot that you can kind of track like when it's using specific data. What's really great is then if you want to help creators monetize using Bitcoin or Ethereum or any EVM chain, you can do that as well. So Chain Fusion allows for any ICP canister smart contract to can call and connect with Bitcoin and Ethereum, including being able to generate like an Ethereum or Bitcoin address directly in ICP's canister smart contract. So in this use case, what you could do is, for example, you could create an ICP canister smart contract, for each creator that's training the model or providing data for the model. And let's just say like every single time, so you might have like another canister smart contract that actually runs the LLM, and maybe another one for the front end, and maybe another canister smart contract for like the tracking of the data. And every single time, let's say like, okay, like a piece of data is being used by a certain creator, can automatically then send like a Bitcoin or Ethereum token to that creator. So I think like that is quite interesting, and that really enables this use case for this like kind of multi-chain layer. And then another value add that isn't listed here, but I think it's also like valuable because like I know that for some of you guys, like you might want to be using like larger LLMs that can't be run on ICP. we also have this feature called HTTPS outcalls. It actually allows for an ICP canister smart contract to make an API request. So in this case, a lot of teams that are tinkering with, are building AI on ICP, and their models are just like slightly bigger. Eventually, heap memory will become like larger. They actually are just then they're using their API. They're calling their API directly in an ICP canister smart contract. So unfortunately, that means maybe like the application is not like completely like a DAI project, because they might be using another like Web 2 service in order to kind of host and train their model. But then in this case, like calling an API with an ICP canister smart contract. But that still is a workaround for now for a lot of teams that do have larger LLMs. For future developments, I'm really excited about all the research that ICP is trying to do with DAI. We recently partnered with Singularity Net to conduct more DAI infrastructure research, and we are with this. We're researching on how to better like host, or how to better like manage, or like train like models directly on chain. So in this case, we are researching like how to like increase heap memory, also increasing like SIMD to allow like multiple processes to run at the same time. So I think that'd be a lot of really interesting future developments, and I definitely suggest that you follow Dfinity as well as Dfinity Dev for any upcoming developments on the research. In terms of resources, there are a lot of resources that are available for teams that are building DAI, and I think these will be super helpful for you during the hackathon. So for example, there is a DAI on ICP documentation. Like we have 2 examples, and then we'll have enough time to go through one example today on how to build that. And there is a DAI on ICP ecosystem projects. These are just a list of ecosystem teams that are building different projects on AI. And so like you can take. I know that I mentioned like about 3 teams, but I think that we're now up to like 13 teams. And then there's also a DAI technical working group, which meets every Thursday at 9 a.m. PST. These are all the teams that are building decentralized AI and ICP. And so like they meet every single week to do demos, to just talk about their needs, as well as there's.
Sorry to interrupt, Jennifer.
Yeah.
Is the meetup virtual or is it like the physical location for the AI one you mentioned?
Yeah, the meetup is virtual. If you click on the link, you'll be able to find like the Discord link where they're meeting.
Perfect. And regarding the links, could we get a copy of this or the link so that we can also share it with the participants after to join and explore more about the DAI with ICP?
Yes, absolutely. Yeah. So I'll share this slide deck with you guys afterwards. Awesome. And then there's also a decentralized AI channel in the ICP developer Discord. A lot of the ecosystem teams are there as well. So like as you have any questions as you're building, feel free to use this Discord. And also there is a DAI working group GitHub. This is also where a lot of teams are posting their open source code on DAI projects. So with that, I'm gonna show you guys an example on an image classification example. So what this does is it uses an ICP canister smart contract, accepts an image as an input from a user, and then runs an image classification inference. And then it uses like a backend canister that embeds like a tracked onX inference engine with a mobile net version 2.7 model. So then we can go through this code here. It is on the Internet Computer Docs. I'll give you guys a second just to maybe scan it and then open it on your computers. Or just type it in the URL. But if you also want an easier way to find this, you can go to internetcomputer.org/docs, and there is a DAI section. And from there, there is an image classification example. With that, I can just now actually like show you on the docs where this is and stop presenting this here. Okay, I'm gonna share my screen right now.
Perfect. Is this going to be the hands-on coding you talked about?
Yes, that is correct.
Yes. Okay. Super excited.
Let me just 1 second here. I'm gonna share the screen.
Take your time.
again.
It's great, and I do want to ask you about it now or later. What would what would be the most awesome decentralized AI app you could make on ICP? Something you'd like to build, because I know you did a lot of hackathons before as well. So say, for example, if you were doing this hackathon yourself, what awesome project would you want to see be built? You can answer it now or later.
Yeah, I think in the presentation, I think there was like two that I think might be really interesting. Like for example, like any like generative art for NFTs. Just imagine being able to maybe generatively create an art piece of artwork and then just mint it as an NFT. I think that's like a simple one for 3 days. And then creating an AI chatbot that maybe would give tokens to anyone that trains a AI chatbot. That might be interesting as well. Just being able to incentivize those who are training models as well.
Gotcha. Could they hypothetically create like a Jennifer AI chatbot, and if people are like talking to Jennifer AI and like pay the chatbot with tokens or get some sort of rewards for it, would that be possible technically? I'm not a technical person myself, so I wouldn't know.
Yeah, I mean, technically, yeah. I mean, what you could do is, in theory, like you can, I mean, me or you as an example, take any of all like the work that I've done, kind of load it up, and then be able to train my data, and then every single time someone uses it, then just send me tokens. Yeah, that's probably the easiest, right? Instead of like that component where yes, maybe in this case, like there's only one creator, right? Because like that's probably the easiest. It sounds like multiple creators, and like maybe there could just be like one person.
Yeah, makes sense. It would be nice to like see an integration with that with open chat as well, so people could like embed it on their profile there and like talk to their AI selves. Okay, I don't want to keep you too much. Go do the awesome hands-on coding. Excited to see it.
Awesome, cool. Well, here I am just sharing like documentation. If you go to internetcomputer.org/docs, like you would be able to still like navigate to the same documentation that I had linked out. So in the DAI section, there is an image classification example where you can just upload this image, and then it should be able to practically, I think it's able to then just practically like tell you like, okay, what what is this? I mean, let's find like a good let's find like a good image, and then this try this out. So yeah, there's already an example of this. So let's just then, in this case, we can go through the step by step here. We can go through the step by step here. This does require some. Does require some prerequisites. So maybe we can start. Maybe we can start with that, because I think that we should have enough time, because this example, has been mostly built out. So first, maybe we could. This is in Rust, so we would have to just make sure that we have like Rust up and running in Mac. So let me just here. So if you clicked on the first link here, this Rust installation instructions for operating system, it will then take you to this page, and then I can go through. Let me just try to share like the full screen so that you can also see. Yeah, you can also see just everything here as well. Okay. Awesome. Give me 1 second. Yeah, give me 1 second.
Yeah, take your time. And a great tool someone I saw suggested it would be nice for developer relations, such as Jennifer, yourself, or anyone who does YouTube tutorials. Essentially, when you want to share your screen, it would mask certain key areas for like security reasons, and that's like a $1 billion startup right there. Target all those YouTubers, and just because you don't want people seeing your keys online when like you're trying to show them a code and do it, and it's free content, and then you might end up losing like a lot of money. Your wallet might be drained because something was leaked online. So they were proposing to make a masking tool for screen sharing tools. It could be like honestly an extension on top of Zoom or OBS to help people do it. ICP, decentralized AI, so many crazy ideas. Generative AI. So, say for example, you could make like a limited edition, 100K, or with generative AI, you could go up to like 1,000 NFTs, right? And then publish them on the ICP blockchain, and do a lot of magic with like the canisters, the Ethereum and the Bitcoin cross bridge activities happening. I feel like we got Jennifer back up here. Okay, I was trying to fill in the dead air while we get here. Yeah, take your time.
Yeah, absolutely. What was the use case that you've discovered from those tuning in?
Yes. Sorry, I missed it. Do you mind repeating what he said?
Yeah, like what was the use case that you were chatting about?
Oh, good one. So I was just telling him someone proposed this solution that say like someone, Jennifer, a DevRel YouTuber who creates coding tutorials, when they're sharing their screen, their keys or sensitive info would be masked and blurred. So it wouldn't be leaked to people, and then people would like be able to access their private keys. So in a way, it's like more secure. It could also honestly be like an extension on top of OBS, Zoom, or something. So it's simpler when you broadcast it.
Got it. Yeah. Is that an idea that they're going to build as part of the hackathon?
It could be. It could be. It wasn't up until now, but now it is.
Awesome. That's good to hear. I'm hoping I'm not sharing anything sensitive, or else,
And it's okay. it's only going to be public on YouTube. The millions could see it. What's the worst that could happen?
Yeah, what's the worst? Yeah, I'll have to change all my private keys. How's that? All right, awesome.
Sounds good.
Yeah, thanks guys for again for the patience here.
Yeah.
Yeah.
Someone has a question.
Yes.
Can we use the ICP in Python?
Yes, you can use ICP in Python. There is a Python SDK called Kybra. If you type in the Kybra book, this is a tutorial on. This is practically a full tutorial on how to set up how to write a cancer smart contract in Python.
Perfect. Thank you for sharing. Someone else did have a question. It was not technical. It was mostly theoretical. We can get to it after the coding one. It was related to decentralized AI and like the implications in the blockchain world. But I'll let you get into the coding, and then we'll get into all the theoretics and philosophies.
All right. Awesome. Cool. And then, yeah, so I'll just go back to the DAI example, image classification example. So yeah, you can find this full source code on GitHub. But yes, I will be able to just go through this. So there are some prerequisites. And yeah, like I know that we do have sometimes we can't go through some of these prerequisites because I think it's important, at least even if we can't get through like all of the downloads, at least get at least most of it so you guys can get up and running. So first is you have to install Rust on your computer. So in this case, because this example is in Rust, so I do have so I believe I already have like Rust up and running. So let me just do it in my command line here. Let me just. Yeah, I should have Rust up. Yeah, I think I should have Rust up, but let me just double check. Yeah, I'm just gonna run this curl. Yeah, so I already have it. Yeah, I think I already have it. So yeah, it's pretty much in this case, it's telling me like, hey, like if you want to modify Rust, you can. But if you don't have Rust when you run this command, you should have this. Rust is now installed. It's installed now. Great. And then, yeah, so I'm just going to cancel the installation for me because I already have Rust. And then I'm just going to double check if I have the C compiler as well. I should have this C compiler. Yep. So yeah, I'm just getting this error because I already have these installed. So in this case, yeah, what I suggest is just like, yeah, just go through these steps to install Rust. And I know it might take a second for you to do that, but then the next step as well as we can really do this in conjunction with each other is installing the IC SDK, which is what is going to be used for you to connect with ICP. So if you so there are like different there are like different tools, like practically what we suggest you to run. So yeah, like there's DFX is part of the IC SDK, which is like what we would suggest you to first run. So here is the bash for that. You would just run this in your command line. I also have this, so I'll also get like an error as well when I run this, but you shouldn't get an error. Like it should go through. In this case, I might not have the latest release. Yeah, so I'm just actually so I already have it, so I'm just gonna cancel it. But yeah, if you don't have it, like once you go through, it will just now install. It will install the Linux. Yeah, so it will install the dfx. And then, yeah, so then the next steps with, with this is to be able to download and install Git. Git is like quite, yeah, it is quite common. Like if you're using like GitHub, or you're using like Git, like a lot of developers should like have like Git installed. So like you might already have this installed. Next is like installing like WASI as well. So yeah, like you do need to install WASI. So let me just install this. Let me, I should have this as well. In this case, yeah, so I should already have, yeah, I should already have this, but like, let me just grab it and download it in case I don't have it already. Yeah, so yeah, I already should have these. So yeah, choose the WASI that you would need for your operating system. In this case, I'm on Mac OS, so I chose the Mac OS version. And then there's also suggests that you like export WASI32 in your shell. So let me just do that myself. I believe, yeah, so I've already done this myself as well. And then, yeah, it actually also asks you to install WASI to IC, because in a computer like itself, like in order to use WASI, it needs like a special library to convert like any like WASI to like a WASM module. So yeah, like you can run through this. So I believe that I also have this as well. So yeah, let me just actually I will still go through the steps myself. So yeah, you ask you to clone like the WASI to ICP repo, and then go through the and go to the folder, and then you can just you should be able to build it. So yeah, so great. I think that's it. I think that WASI2 I see. Let me just try to add it to my path as well. Actually, let me just go through downloading the example, and then I can show you guys practically, yeah, like, and if we run into any errors, we'll take a look at that as well. So yeah, what you could do is the next step is the example is in this examples file. So you would do git clone like this here, like, but if you want to actually just see the full repository, so practically in github.com/affinity/examples under Rust, there should be then an image classification example, and this is the full example. So let's just say, like, okay, if you didn't have time to go through those prerequisites, or you just want to listen today, you can always just go back here and be able to, yeah, just be able to just take a look at this full code and then be able to run it. So yeah, for me, like what I believe, I already have these examples, and then I will do a git pull origin master just so that, yeah, just so that I just make sure that I have like the latest version. But yeah, it seems like I already have the latest version here, so I'll get actually go out to master, and then I'll just make sure that I have the latest version I'll also make sure that this is a little bit bigger so everyone can see as well. So I'm just gonna pull, and yeah, it seems like I do have the latest version of the examples repository, so I should have that Rust classification. And then what I'll do is I'll just like load the example, but then I can go through the code and just kind of show you what's actually going on. So let me just go to the examples /rust/image classification, which is where this repo is. Yeah, actually, I've already am in examples. And then let me just download this to then, okay, and I will, run this. And the next thing so practically this example has already been built out. So the next thing that I would just need is like the concept of deploying the code. So I'll do like a dfx start -clean -background. This is when you have like ICP or the ICP SDK like up and running. You should then be able to do like a dfx start -clean -background to run ICP run ICP like locally. And then I'll be able to start. So it seems like I already have the ICP already running in the background. So that's why I'm getting an error. But the next part is to actually deploy to like in general, like I think like we can, in this case, I think we can deploy this like locally just so we can see how it works, but you can also deploy directly to the ICP blockchain. So we just actually want this to actually run. So let's do a dfx deploy. And this is probably what you guys, okay. Yeah, I'll just take a few minutes to deploy this. Okay, so it looks like, yeah, I was unable to find the WASI to IC. Let me just, yeah, we should be able to just add it to the binary. And I thought I already had it up and running, but okay. But let me just do that. Let me do that just real quick. In the meantime, yeah, let me just do that real quick. Yeah, in the meantime, feel free if you have any questions to ask it. Okay, let me just make sure. Okay, I think my WASI is in. Yeah, let me just clear this out. So practically how we would do this is, in this case, let me just go back as well. I think WASI2 IC. Okay, I think now this should be. Okay, perfect. So yeah, I think now I should have assigned the binary correctly. So practically, wherever you have WAS that you clone WASI to IC, yeah, you can run this command here, and I'll make sure that's like updated in the docs as well. So practically, I had it in my documents folder. So practically, do an export path equals $path :/ to WASI IC, but whatever the path is in that folder, that's what I suggest. Now let's try to deploy this again. So yeah, so in order to deploy, you have to be in the root file, like the root folder where your project is. So in this case, like I wasn't in the examples. So let me just go in again. So it was cd rus, then image classification. Okay, it seems here that it's still having find command or file WASI IC. Let me just double check this one. Okay, cannot find command or file WASI IC. Let me just double check again here why it's not showing me this. Just 1 second. If not, we can also go to the machine learning example because I think that there might be an issue with WASI2. Like there might be an issue to WASI. Like there might be something that I'm not configuring properly, or there's something wrong on this end. So like I can just follow up. Yeah, I can follow up with that because I know that we have like 30 minutes, like 30 minutes left. So there is this example here with the image classification and then, but how about like this? I know that like this might be a better example because like we are copy and pasting code and not using like a just like our existing so yeah, we are in this machine we aren't like using like existing like built out like built out. One, so like this machine learning sample might be like a good example actually, because yeah, in this case we'll be copying and pasting. So practically what I really like about this example is what at the end, like what we'll be able to do is like we're able to actually like draw like a number. I'll show you here. Like, so practically you'll be able to like draw like this number, and then it will just be able to tell you, okay, well, this is an 8. So let's try that. I think that would be also be fun to go through as well. And yeah, there's are like ways that you can copy and paste code and go through there. So let's just get out of this. So okay, so when you can now like do like a dFX, you can create like a new dFX code. So for example, let's just say like a new folder like dFX new machine learning. In this case, we want to use Rust, but like to the user, to the developer that did ask, oh, can I use Python? You should be able to use Python. So when you create like a dFX new, whatever your project name is, then you should be able to choose this. Yeah, you should be able to use this Python. It will just automatically create you a Python, is a like Python project. And then here is the Rust. And then, yeah, like I think here what mentioned is vanilla JS, but you can use any other like front-end framework, whatever you are most familiar with. And then from here, yeah, you can choose, like there are other extra features on ICP that are like you want to include. So inner identity is this authentication framework on ICP where you can sign into a dApp using a fingerprint, like any passkey such as like a fingerprint or Face ID. It's really good for app authentication. So if you want to include that, or there's also so at Bitcoin, also like front-end tests. In this case, I don't think I'm gonna be adding any extra features. I don't think it's needed for this example, so I'm just gonna click confirm. But if you wanted to, you could. Okay, and so then in this case, I will now go to my machine learning. Okay, great. Okay, so then we can then go to I'm gonna do this dual screen here, where I'm just gonna show Visual Studio Code. So let me open this file. I could, and there's also another way you could do like code dot and should open a new, like the same file but I didn't do that. But if you ever want to do that, let's say like, hey, you want to open this folder on your machine, you can also just do like a code dot, and then it should open it. It should open it for you. But yeah, okay, so then let's go through these steps. Okay, so first, there's a backend canister. This is practically where we'll be able to, yeah, this is practically where like our inference code will be, like our model will be located in. So in a typical like ICP project, like you can, for example, you can only just host your front end or just your back end on ICP. But in this case, we have a back end and a front end. And how we know like it's an ICP project is there is always this like a dfx.json. This is kind of like the core of your ICP project, and practically like what's actually being deployed, So we talked about canisters. Canisters are these smart contracts you can deploy code to. And so in this case, there's a machine learning dash backend, also machine dash learning dash front end. And yeah, practically this is outlines what exactly it is. In this case, this is a canister that's based on Rust. And this is like an asset canister, which we just call it. It's kind of like it's like a front end canister. Yeah, so like the dFx.json is kind of core of the ICP development. So in this case, it's telling us, hey, let's just then go to lib.rs. And it originally it's a hello world, but in this case, let's then we're gonna use like I think like the mince inference. So like let's load that up. So it's just gonna tell us, hey, let's load this up in the backend. And then I probably would have to run yeah, in the future, yeah. So at the end, yeah, I'll probably have to just like run this. But then in this case, the other thing that we'll have to do is we have to actually create the model. So the next thing is we'll create a model.rs. Or I believe we should create like a folder within src. Or yeah, I think that there is, okay, maybe this is, yeah, we'll create another like, yeah, so we can just create like a model.rs here. And this is this will handle the user input, for example. Let me just make sure it is a Rust file. So you would know that if you see this, Rust icon. And then this is what practically like what handles the user, like what handles the user input. And then, yeah, we'll be able to like write a few numbers. And then the next thing that we'll have to do is just be able to define the machine learning model. And so we'll have to have like a state.rs. And yeah, this is like practically, these are like the parameters that are used. I think like we created this, accuracy of this model should be like 98.67%. So unless we do something really, really wrong, this should have a problem. So yeah, there should be like in your machine-learning-backend in your state.src, that state.rs, yeah, you should then be able to copy this code here. And then, yep, and then we need to create then another file that practically is able to load this model, which is like we need to create like a web.rs, and this is the code that will actually be able to load the model. Let's see here. Oh, it's a web.rs. All right, so this is a web.rs, and this is what will load the model. Okay, so you can see here there's a whole bunch of red marks here practically because we haven't loaded any of our packages. So we do need to update our cargo.toml file to just then load up all of our dependencies. So I think in here, we're missing some dependencies. So let's add these dependencies, and voila, it's no longer red. So yeah, we were just missing some packages. And then the next thing is we'll also need to update our did file, or which is like the candid service file. So ICP uses this language called candid to practically create it defines a public service. So practically, like, if it practically like kind of defines what functions are in the canister. So there's a ways in order to just automatically generate this this file, and you don't have to like learn too much about like what candid is or like how to write in candid. So this is just more of, yeah, this is just, and in this case, like yeah, we do like, we can just copy and paste this, we already have this, but there are ways if you want to dive in deeper to just automatically create this to create this for you. And then we also will need to then download the binary file for the model. So next step here is we'll then need to run this here. Let me just make sure. Oh, so yeah, we have to be in order to run this, we have to be in the learning. I think, oh yeah, I'm in this machine learning backend. Okay, let me just get wg get then. Okay, so in this case, yeah, so what I can do here is I'm just going to install wget. So brew install wget, and then hopefully we should be able to get the model. And yeah, please, if you guys have any other questions, please feel free. So now, yeah, I think now we have the model. Now we should have the model now. And now, like, let's create the front end. So we talked about, okay, so we talked about like how ICP as well can also look like we can actually have like a decentralized front end like loaded as well. So in this case, yeah, what's really great about ICP, as I mentioned, you can have these like full like backend and front end services on ICP, so including a front end. So that's what makes it really great. And so yeah, let's like create that front end where we could use it to then we were able to use it. So let me go to the front end here, and then there should be a HTML file that we can update. So this is yeah, this is practically like what the user interface will look like. Here is just like a simple HTML file. It's already been built out for us in this case. And there's also then an index, like an index.js that we can get access to, or should it be an app.js? Okay, let me just double check here. Okay, yeah, we'll just create another like, then we can create, I think we can create an app.js. Yeah, it's an app.js. So, and actually like what we could do is actually, like, yeah, I'll just create like an index.js right now to store this here. This is practically calling your backend. So in ICP, there is this like, so when I was talking about, the like this backend here, when I was talking about this here, this candid file, in order to call your backend or any of like the functions in your backend, the candid file kind of powers that. So then, yeah, candid file like kind of powers that. And what you could do is then you can just call like, yeah, like call the backend. So let me just make sure here. It looks like there might be a couple of areas where we're not properly calling machine learning sample instead. And instead we want to use machine learning. We want to instead call it machine learning backend. So want to make sure, yeah, we want to make sure that, yeah, so anywhere in this case, like, because like it looks like this example did like use, for example, like machine underscore learning underscore sample underscore backend. So anywhere like they might have like said machine underscore learning underscore like sample, like I'll just remove that. And then with like what I have here. So I'm using like machine learning backends. So in this case, actually, I probably should do that instead. Yeah, so yeah, I'll go through that. And then yeah, like, so, and also we'll need to configure the dfx .json file here. So here, for example, yeah, like it will practically, yeah, so practically be, this is the dfx JSON file, like I mentioned. This is kind of like the core of your ICP project. And we just have to make sure actually that pretty much everything aligns. So it seems here that, yeah, so in this case, this sample does use like different names, and I use like a different name. So just make sure that your files that are listed here are pointing to your actual files in your GitHub repository. So in this case, that's what I'm trying to do. I'm just trying to make sure that everything aligns, and I'll go back and I'll do the same for I'll do the same for everything else as well. And yeah, I probably should just have used okay, here. And then in the index dot, I also think that we might need to do a dfx generate. Okay. Yeah, there's also another point here where we'll have to do like a dfx generate, which give one more. I think there's another area where we might be having just like the wrong yeah, so yeah, I just have to just make sure these are correct here. Probably should just have use whatever okay, let me just make sure. Okay, so here, like assets, the disk folder. Okay, yeah, we also have to do npm. So I also have to probably build this as well. Yeah, let me just like build this quickly. Okay, so here, src machine learning dash front end dash assets, this machine dash learning dash front end. Yeah, this is correct. This is correct. Let me just remove these decorations. They're just like, yeah, I'm just having this, it's just not like, it's thinking that, yeah, so here, if I do an NFM relic generating, local canisters. Okay, let me just make sure, where is this? Asset storage dot did here. And then, yeah, I'm just trying to, yeah, so src. Yeah, just trying to make sure that the workspaces are named are correct. In this case, it looks like there is some sort of there's just some sort of error that's preventing me from running this. Okay, I think exactly. I now I know what I'm supposed. Now exactly. Yeah, I think I know what's the issue here. Give me just one moment. Practically, I think the issue is, yeah, it's just, so there is an HTML file. I think I might have missed just like one step. Yeah, I think I'll just machine learning backend. Yeah, so I think here this is probably where we want to practically have index. Okay, it's still giving me this error. Let me just like double check this real quick and dfx. Oh yeah, it's like yeah, it's probably, yeah, it's looking for that candid. Oh, it's probably looking for that candid file. Let's see here if we can do a dfx generate. Yeah, it's saying that this. Okay, let me just add it at this file. It says that, yeah, it doesn't have that file, but let me just add it like manually. Yeah, let me just add it like manually. So it says it needs this. Okay, let's in the canisters. It doesn't have. It's saying it doesn't have this. So let me just add it like manually. So it was like machine learning, front end. And then it needed like an asset storage .did. Not sure like why it didn't automatically create this. I have to double check. I have to double check on this. But then hopefully this should machine learning. Okay, it's dash. Okay, and then now, yeah, now I think this should be good. Let me grab this full file. Okay, this is this full file. Okay, let's see if this will work. Okay. All right. So yeah, I did create so yeah, like there was this. I'm not sure like why I didn't have this asset sort that did, but I added this. And the next thing is it's just then trying to yeah, then it's just trying to run. Like we're just gonna try to like fix the errors like we're running the back end. So let's just take a quick look here. It's saying that IC Mint's back end is not found. I know that we have a couple minutes. There's a couple of minutes left, but hopefully we'll able to have this up and running by then. Okay, so it's saying that, yeah, they're not able to find our IC mints package. So our package, did we call it something else here? Okay, let me just like double check. Yeah, like we did call it. Let me just make sure that in the backend folder we did actually. So let's see now if this will work. We did download the binary file as suggested here. In this case, okay, let me just do a VFX generate again. Okay. It looks like it's not able to recognize the machine learning, but let me just like see. One thing that we could do that would be, but in this case here, it just, yeah, in this case here, what it is like, okay, it's pretty much just saying like, hey, it's not able to recognize IC like mints for some reason. But I believe I do have like a working version that I can at least share with you guys. Let me just show it real quick. I think like that. This would be pretty cool. Yeah, like a pretty cool application in this case. Give me just 1 second. And yeah, so this is what would have been the final result. This would have been the final result. So here, what you could do is, yeah, like if you want to type in. So I remember like we had talked about just going into the internetcomputer.org/AI /docs. So /docs, if you go to, and then if you go down to start building here, and then if you go to this DAI overview, this is practically what what would have been like the final case. So you want to draw a digit here, just for the sake of time. I think that we were unable to figure out like why IC mints wasn't loading, but in this is the sake of time, this would have been the final product. So you can just practically draw any number from like thanks like that, like a dot. Draw any number from 0 to 9, and then it just should be able to pretty much. So in this case, oh wow, in this case, it might not be always. It should be accurate. Make sure that. Yeah. So in this case, yeah, like so, whatever bad handwriting you have, let's see how bad your handwriting is and how good the AI can actually detect what number that you write. So with that, that's it for like pretty much everything that I have to show you guys. So it sounds like, yeah, like there are some things that for the live coding session we'll have to figure out, but hopefully that kind of gives you guys a good overview on how working with DAI and ICP, like how working with DAI and ICP looks like.
Thank you so much, Jennifer, for the wonderful tutorial. Super lovely, super helpful. Yeah, every single time, like we do these workshops, I learn a lot myself, and this would be so useful for my friend. He has such a bad handwriting. He thinks it's cursive, but it's not. So someone should tell him that. And yeah, this is super nice. Someone did have if you guys have any questions, please put a comment on the YouTube, LinkedIn, or Twitter, and then Jennifer could get to it. But there was a question, and this is the one, the philosophical, theoretical one I mentioned, and if I could still keep you on for a few more minutes, so we could touch upon that as well. They were asking, and I think it was Martin that also asked, how does this tie into generative AI? I feel like we did touch upon it in the beginning a little bit, but challenges of Gen AI, how can you prove that I'm the real Poria right now, like talking here, to verify it? So one aspect is like with the blockchain, the authentication, to do that. Other challenges that Gen AI faces, and how do you think ICP slash the blockchain can help address those?
Mhm. Yeah, like I mentioned, like mentioned earlier, like one of the biggest challenges of generative AI is just really knowing, like, what data is being used to train those models. So the blockchain can definitely be used to really be able to track which, like, be able to track which data sets are being used to train those models. Also, something that's quite interesting that was a project idea, but I think its implementation is still like a far a ways along, is being able to track like a response from a generative AI bot, for example, like Midjourney or ChatGPT, and just be able to check if someone used generative AI for any of the work that they've done. So in this case, let's just say like someone uses like Midjourney to mint NFTs. Potentially, Midjourney could create like a data, like just like a hash map, or just some sort of like queer, like they can store the data of like what is being generated from their chatbot, and then someone can then see like all of the images generated from their bot, and then if someone then takes that and then uses it for any other use that isn't permitted, then there's a way to there's a way to kind of call out on that. I mean, in terms of like the technical implementation, you can do that right now. It's just of course for like what's the enforcement, that's a little bit more difficult.
Yeah, that makes sense. The proof, that the stamp of saying like, is this AI generated or not, is one of the simplest ones. One of the most important ones as well. It was also Galvin Josh on LinkedIn. He had this question: scalability, interoperability, and data privacy concerns in terms of putting AI solutions on chain, and how can it be addressed? I feel like in your response, you touched upon that. Sarank also has a question: can we increase inference time using ICP?
With that, I would have to just double check. Let's double check on that. Yeah, I don't really know. I don't really know the numbers behind, how much, like how we're able to do that.
Makes sense. Yeah, anytime you did get a chance to look into that, we can share it with them. Perfect. If there are no more questions, any last thoughts, Jennifer? Any inspiration, tips as they head into the hackathon? Because you've done 15 hackathons, and you know what's happening. Just share your best tips, do's and don'ts, anything.
Mhm. Yeah. Oh, actually, like to go back to Josh's question, we do actually also have a feature called vet keys, where you can actually store secrets on the blockchain. So you can practically set certain things that you like, say like load up onto ICP, and just say like, okay, only these wallet addresses or only these principals on ICP can actually view it. So that feature is called vet keys, VETKEYS. So I think that might be some interesting things where maybe you can make certain just certain things private to a certain number, to a set of people. Exactly. Thank you. Yeah, for me, like I would definitely say to start thinking about your idea now. Yeah, I have like and use the time that you are actually at the hackathon, just like start coding, because I think a lot of the, even like as you saw in my demo, we had everything step by step, but even then sometimes like certain things like don't work, and like our code is still very unexpected. So if you come in with your idea and you just are able to just focus the whole entire time on coding, I think like you're more likely to build something more substantial. So you have a week, so hopefully you can come up with some sort of conceptual idea, and then once you're there at the hackathon, like it's more a matter of just like finding a team member and just refining that idea, and then you can get coding right away.
Yeah, that's perfect. That's such a valuable tip. Something we're encouraging everyone is to just like start preparing, start teaming up virtually right now. We'll also give you a list of ideas to go over. On that note, I remember on the GitHub repo, there was some list of requests for projects part of ICP. Is there like a specific like 2024 list right now based on like what's on top of your mind, the foundation or ICP, to be like, if these projects get built, like we'll back them and like support them, and it'll be so exciting for the existing community and the future users to use as well?
Yeah, there's an ICP request for startups. Let me just grab that here. So yeah, there is a repo called github.com/definity/grant-r FPS. Like I will share that with your team at BLoud. But yeah, this is practically just a list of RFPs and bounties that we have, as well as requests for startups. This request for startups are just like the list of the most like the startups that we are most we're looking for the most. And then like we do have a grants program. So after you build your hackathon project, if you want to apply to our grants program with any of these ideas in mind, we definitely would encourage you to.
Perfect. Sounds good. Also, the grants program, they could apply to it. Regarding the is it called the foundation grants? Because something that we're putting up for the hackathon, the 3K prize, part of ICP, 2K for the winner and 1K for the runner-up. How would the process of redeeming that be? And would you be the best person to explain it, or Hobby?
Yeah, so for the prizes, I definitely think Javi is probably the best. We also have like a Dfinity developer grants program, which I'm also a part of that team. We do offer 5,000, 25,000, and $100,000 grants, 100,000 more for like returning grantees. That's also another program post hackathon that you can take advantage of.
Perfect. Sounds good. Thank you so much for your time, Jennifer. What we'll do is if we could get like a copy of like a few of the slides, links, so we can also send it to them directly to all the attendees and existing participants. It'll be super valuable, and super excited for the hackathon. And we hope to see you there either in person or virtual.
Yeah, thank you so much again for inviting me. Hopefully I'll see you guys online, and please feel free to reach out if you have any questions.
Perfect. Thank you so much, Jennifer. You take care.
Great.
Have a good
Thank
day.
you.
Bye-bye. Bye.
Bye.